I've shown how to set up a debugger in the Arrow C++ project in the instructions linked in the description. That's shown in this launch.json file, with one for C++, for Python, and for R. Let's look now at how to use it. When you run the debugger, it needs to know which binary is being run. For C++, that's going to be the test binary or the program binary. For Python and R, the binary will be your Python or R interpreter. So let's first look at the C++. Let's say that we're trying to test this struct field access, and we specifically set a breakpoint in this particular function right here by clicking on the left part of the code. In order to run this unit test and hit that breakpoint, we're going to need to launch the debugger. In the debugger configuration, we have the program, in this case, set to the test executable. Arrow array test is the one that we're going to be testing. If it's a different test, we would have to point it at the other test file under this debug directory. Under args, we can pass in a particular filter for which test we want to run. Currently, we have it set to the struct builder.test append null, which is this test here. To run that test, once we have these two fields filled in, we can go over to the Debug and Run tab, select our debug C++ unit test, and press F5. It will take a moment to load up the debugger, and once it does, we will hit our breakpoint that we had set previously. We'll look after this first part at how to actually use and navigate. For now, we'll exit out right here. R and Python are a little bit different. In this case, instead of going towards the executable of the test, because there's no executable, we have to go towards the executable of the interpreter. So for Python, we have this handy VS Code command that tells it to go towards the interpreter path, whatever it is that is the current Python. The request mode is going to be attach, because we're going to, instead of have the debugger start the process, we're going to start Python and then attach the debugger to it. So in order to run the debugger with the Python unit test, we'll open up our test file, and in the test we want to do, we're going to add a breakpoint line, or a breakpoint call. And when Python runs this test, it'll stop right here with the Python debugger open. So let's go ahead and do that. So I've already gotten into the Python directory in the Arrow repo in this terminal down here. And so we'll run pytest, pyarrow, and then we'll go towards that file just to run that single file. Pyarrow tests test struct array, or sorry, test array. You see it's run, and it's gotten to this point right here where we put in our debugger statement. From here, in order to attach, we first need to get the process ID, which we're going to be prompted to by the debugger. So we'll write import os.get PID. And that's our process ID. Now we'll choose the LLDB attached to Python, F5, and then it'll ask for our process ID. We'll paste it in, and then it'll take a second to load. And now we have the debugger attached, but we're still stopped here in the Python debugger. So to continue forward into the C++ code, we'll press C for continue to let the Python continue running. And once we do that, we'll go and hit that breakpoint that we set inside the C++ code. So in order to get out of that, we'll just disconnect, let the Python test continue. The process for R is very similar to one for Python. The one thing that's going to be different is that R doesn't have a convenient sort of shorthand for finding the R executable, so you'll have to find that yourself. This varies by operating system and just how you install the R, but for me it is at this location on macOS. So sort of like we did with the Python, we're going to add a browser call, and this is going to stop it in an interactive session there so that we can get our process ID and attach for that unit test. So we'll move over from the Python directory over to R, open up an R terminal, and then we'll run the tests. So DevTools test, we'll filter for this specific file, which is array. And now we've hit that browser call. And so sort of similar, we will call sys.getPID, and that'll get us our process ID. We will choose LLDB attached to R, hit F5, and paste in our process ID. Now that it's attached, we can again press C for continue, and then we will hit our breakpoint. And that's how to get attached with the debugger in C++, Python, and R. So now that we've learned how to attach the debugger, let's look at how to use it. I've set a breakpoint in a more interesting part of the code that we'll be looking at inside of the Parquet dataset handling in C++. I've already pointed the launch.json configured to a unit test that'll get to that breakpoint. So let's go ahead and press play on the debugger, and it takes us to our breakpoint. So a few things we'll be able to see on this debugger pane on the left. The first is the variables section. We can see the various local variables and open and introspect them. Some will be somewhat useful. Pointers and shared smart pointers are less easy to look through, but this gives us a basic way to look through these variables. At the bottom of here is the call stack. And if I expand that, we can see our location currently, but we can also go up levels to see what is calling that function and what is calling that function. And this is really helpful for figuring out where in the program you are or how it is that the program got to this particular function. In addition, it lets you trace variables and how they've changed as they've been passing through the call stack, because each time you change a level, you'll notice the local variables and everything else changes with it. So you can introspect not just the variables at the place that you're stopped at, but anywhere else along the stack where you're stopped at. Even more than that, if you look at the top of here, we have this TID, that's your thread ID. And if you collapse that, you'll see that there's actually two threads, and we can see that the other thread is also paused. And so we can go over to the other thread and introspect its current stack right now. Often there's another thread that's waiting, but sometimes it's helpful to understand, if you're brought at a breakpoint, what are the other threads doing at that time? Some things you can't see by introspecting this local variables thing, by just clicking through. So instead what you can use is this debug console, which allows you to interactively call functions on classes. For example, we know that we called up here this isLeaf function, so maybe we can call that. So I can do print schema field isLeaf, and that'll show me that that was true. Or for example, there's this field we extracted that's an arrow field. Let's show its type. So we do print field type, and most arrow types, including the data types, have a toString method. So we'll call the toString to get that. And now we see it's double. This function is actually called in a loop several times, and so it's helpful sometimes if you want to get to the right iteration to be able to watch those variables. That's what this panel is on the left for. If you're using LLDB, you're going to have to prefix your watches with this NAT for native. And so we'll do our field type toString here. As we step through the code, this will update and we'll be able to see that value interactively without having to continuously enter it into the debug console. Next, let's talk about actually stepping through the code. Up here we have the various buttons for going through, so we can just go forward until the next breakpoint or exception. We can press this to go to the next line, and that's a way to iteratively step through, but that'll sort of step over the calls. If we want to go down a level, we go here. So I think this point will go into the num values function. And that's just extracting that internal variable. So we go step over, it'll take us back. We can also go up, and so that would have us finish the current function and go up the stack to this test row groups. And then of course we can completely restart the debugger or just stop. Another thing you can do is of course set additional breakpoints. And then now when we press this play button, it'll go straight to that breakpoint. Easy if you know where you want to go next, you can just skip directly to that spot rather than trying to navigate line by line. And that's the basics of how to navigate the debugger.